This is college mathematics, fourth semester TDC.part University, vector analysis. This is vector analysis. Now I am going to solve this. This supplement problem set 14. So my first question is find the value of question number 1. Find the value of x such that the vectors k I cap to j cap minus k cap and x I cap plus 4j cap plus 5k cap are coplanar. So for coplanar, a vector dot b vector cross c vector is equal to 0. So 0 0 1 1 2 minus 1 x 4 5, this is equal to 0. So this will be 1 remains here, so this will be 1 4 minus 2x is equal to 0. So 2x is equal to 4, x is equal to 2. This is your answer. Now question number 2. So that a vector cross r vector cross a vector is equal to a vector cross r vector cross a vector. So here you see one thing, that is left hand side, your a vector cross r vector cross a vector. So here a vector r vector a vector goes like this. So first this side, then this side. So this will be a vector dot a vector r vector minus a vector dot r vector a vector. Now your right hand side, that is a vector cross r vector cross a vector, again this you can write it like this, minus a vector cross a vector cross r vector. So this will be minus, again this is a vector r vector, this. So first this side, then this side. So here a vector r vector a vector minus a vector dot a vector r vector. So this will be equal to minus a vector r vector a vector plus a vector dot a vector dot r vector. So you can write this as a vector dot a vector dot r vector minus a vector dot r vector a. So you can see this is equal to left hand side. So this is equal to left hand side. Now question number 3, that is if a vector b vector c vector are non-coplanar vector vectors, then so that A vector cross B vector, B vector cross C vector, C vector cross A vector are also non-coplanar. To prove this, we have to prove that this your B vector cross C vector, C vector cross A vector cross B vector, this is equal to A vector, B vector, C vector the whole square. This you have to prove. So this question, it is done in your book. It is same type, it is done in your book. You can see here. This is the question which is done in your book. This is done in your book. You have to prove this. So here what they have done, that let B vector cross C vector is equal to P vector, and C vector cross A vector, that is equal to Q vector, and A vector cross B vector, that is equal to R vector. So now your left hand side, that is B vector cross C vector, C vector cross A vector, and A vector cross B vector, this is equal to P vector, Q vector, R vector. So this is P vector dot Q vector cross R vector. So now this is again P vector dot Q vector cross, instead of R vector you can write A vector cross B vector. See here, this is R vector. So now this will be this is equal. So this will be P vector dot, again you can write this as Q vector dot B vector A vector, Q vector dot A vector B vector. You can write like this. So this again you can write as P vector dot A vector, Q vector dot B vector, P vector dot B vector, Q vector dot A vector. You can write like this. So now you can write again so here again you can write, that is, instead of P vector you can write, that is B vector cross C vector dot A vector, and instead of Q vector you can write C vector cross A vector dot B vector, and minus P vector you can write as B vector cross C vector dot B vector, and here C vector cross A vector dot A vector. Now you can see one thing, that is, that is your that is your B vector cross C vector dot B vector, that is B vector, you can write this as like this, you can write this as B vector dot B vector cross C vector. So see B vector, then C vector, this, so this you can write as also C vector dot B vector cross B vector, and this is equal to 0 because sine 0 is 0, so this becomes 0. So you can write this like this also, this is 0. So now so your again this is C vector cross A vector dot A vector, this is 0, so it remains here only B vector cross C vector dot A vector and C vector cross A vector dot B vector. This is it remains. Now here you can see again your you can write this as A vector dot B vector cross C vector, and you can write this as B vector dot C vector cross A vector. Now you can see here this is A vector, B vector, C vector, goes like this. So here this B vector dot C vector cross A vector, this is all equal to your A vector dot B vector cross C vector. So you can write this as A vector dot B vector cross C vector. This also you can write as A vector dot B vector cross C vector. So this is A, B, C, and this is also A and B, C. So this is equal to your A, B, C the whole square. This is right hand side. So now your second question. Now your second question. Now your third. Now your fourth question. That is, find the value of x such that the vectors 2i cap minus j cap plus k cap, I cap plus 2j cap minus k cap, xi cap minus 4j cap plus 5k cap are coplanar. So again the same condition, A vector dot B vector cross C vector is your 0. So here 2 minus 1 1 1 2 minus 1 x minus 4 5, this is equal to 0. So this is equal to 0. So now I will just expand it. This will be equal to 2 10 minus 4 plus 1 5 minus this and this 5 minus x, say this and this goes, so 5 minus 1 is plus x, and then 1 minus 4 minus 2x. This is equal to 0. So here 2 into 6 plus 5 plus x minus 4 minus 2x equal to 0. So this will be 12 plus 1 minus x equal to 0. So your x will be equal to 13. This is your answer. Now question number 5. So that a vector cross b vector cross c vector is equal to a vector dot c vector b vector minus a vector dot b vector c vector, and is the vector triple product associative. So here you see this question number 5. Question number 5, it is done in your book. You can see that question number 5. This is see this so that here you can see that so that a cross b, this is equal, this is this proof is done in your book. It is done in your book. Here it has proved, this is done in your book. Now I am going to do the is it a triple product. So here you see associative. So a vector cross b vector cross c vector, this is equal to a vector c vector b vector minus a vector dot b c vector. Now here this is your left hand side, and your right hand side, that is a vector cross b vector cross c vector. This you can write as minus c vector cross a vector one minute, this is cross cross, so cross b vector. So here this is, so it is associative, so we have to show that this is associative. This is associative, so this again the same procedure, that is this is c a vector b vector goes like this. So first this side, then this side. So this will be minus first this side is c vector dot b vector into a vector minus this is c vector dot a vector and then b vector. This is, so the same procedure you can do here. So here this will be minus c vector a vector plus c vector a vector b vector. So this will be c vector a vector b vector minus c vector b vector then A vector. You see that is your left hand side, because here it is A dot B, here it is C dot B. So your left hand side is not equal to right hand side, so it is not associative. Now, so it is not associative. Now I am going to question number 6. Here you see question number 6. Question number 6, if A vector, B vector, if A vector, B vector and C vector are any three non-coplanar vector, then so that B vector is equal to A B C vector, B vector cross C vector dot A vector, C vector cross A vector, C vector dot B vector, and A vector cross B vector, C vector, your B vector. This is B vector dot B vector. Oh, I made a mistake here. That is your B vector, that is equal to A C vector, B vector cross C vector, B vector dot A vector, plus C vector cross A vector, B vector dot B vector, A vector cross B vector, B vector dot C vector. This. So how you will prove it? So it is this such type of question is done in your book, and it has to become non-coplanar, to be non-coplanar it must be to be non-coplanar, it has said that to be as a linear combination. That means B vector is a linear combination is a linear combination of three non-coplanar vector. This is given in your book. So therefore your B vector is equal to L B vector cross C vector plus M C vector cross A vector plus N A vector cross B vector. Now first of all I am going to multiply this by A vector, so this will be L A vector B vector cross C vector, M B vector C vector cross A vector, and this multiplying by A vector, and N A vector dot A vector cross B vector. So these two vectors are 0 because I have shown you in your earlier proof. I have shown you in your earlier proof, that is here you can see, because two similar vectors are there, so it is 0. I have shown you earlier. So here this two similar vectors, so this is 0. So B vector dot A vector, that is equal to L A vector cross C vector. So here B vector dot A vector by A vector dot B vector cross C vector. this is equal to L. Now similarly if you multiply this by B, then your B vector dot B vector will be, if you multiply by B, so this will be 0 and this will be 0, only this remains. This is equal to M B vector C vector cross A vector. So your B vector dot B vector by B vector dot C vector cross A vector, this is equal to M. And again if you multiply B vector dot C vector, so here this will be 0, this will be 0 and this remains here, so this is equal to N C vector A vector cross B vector. So your B vector dot C vector by C vector A vector cross B vector is equal to N. Now you place this value here, so your B vector L value B vector dot A vector by A vector dot B vector cross C vector into B vector cross C vector, and value of M is B vector dot B vector into C vector cross A vector divided by B vector dot C vector cross A vector, and here this is N, value of N is this, is B vector dot C vector A vector cross B vector by C vector dot A vector cross B vector. So here again all these three are equal, so B vector is equal to 1 by A B C, so this is equal to, you can write this as B vector cross C vector B vector dot A vector, and again C vector cross A vector B vector dot B vector, and this A vector cross B vector B vector dot C vector. You can write like this. So this is proved. This is proved. Now I am going to question number 8. Question number 8. Question number 8. Question number 8.